Alright, so let's talk about parametrics. Most of the time, we're used to seeing equations like y equals x squared, right? It's one equation and it's one relationship. But in parametrics, we split things into two, right? So y equals g of t and x equals f of t. So that means instead of y just depending on x, both x and y depend on a third variable, which is t. And t you can think of as time. Usually it is time. So imagine a particle's moving, like along a curve, whatever. The x tells you the horizontal position, y tells you the vertical position, and then t is as time goes on. All right. So let's get into some practice problems. Eliminating the parameter. This is the first thing we want to really get down. So sometimes they want you to convert this into a normal equation, x equals t squared, y equals to 2t. And College Word's going to tell you, convert this to a normal equation. You're probably going to see at least one question on the FRQ like this, so make sure you get this down. So step one, you have to solve one equation for t. It doesn't matter which one. I'm just going to solve y, because it'll be easier for me. So y, I just have to divide both sides by 2, right? So that means y over 2 equals t. Right? And now I just I plug this into the other equation for t. So that means x equals y over 2 squared. And then I could simplify this, right? So it would be square root x equals y over 2, which is equal to 2 root x, and y equals 2 root x. All right? So this is basically how you eliminate the parameter. It's very simple. Parametrics in general, at least when I learned it, I thought it was, one of the easiest Calc BC topics. You just have to get some practice in and it should be a breeze. But this is all you have to do for eliminating the parameter, right? So again, step one, you solve one equation for t, and then you plug it into the other equation. Now, let's talk about finding the first derivative. Now, this is like a super important formula you're going to need to know. dy dt over dx dt, right? We want to find dy dx, not dy dt, right? So usually we would just take the derivative of this. But that's not how this works now. We want dy dx. So this is what we do. And this equation makes sense, right? Because we can just, the dt's cancel out and you're just left with dy over dx. So it's not like something you have to memorize. You can like figure out pretty quickly. But let's do that, right? So let's do an example. dx dt is what? Let me use orange. So dx dt, well, the derivative of t squared is just 2t. And then dy dt, the derivative of t cubed is just 3t squared. And remember what we said, we just have to divide, right? So dy dt goes on top, so it's 3t squared over dx dt, 2t. And that simplifies down to 3 over 2t. And boom. That's our slope for the curve. All right? So it's not something that, that's terribly hard. You just have to make sure that you're doing dy dt over dx dt and not just taking the derivative of dy dt. All right? So let's keep going. Find the equation of the tangent line at t equals 1. This is very similar to when we first in Calc AB, when we did derivatives, and then they're like, oh, find the equation of this line, and then you have to use point slope form. Whatever. I'm going on a tangent. Get it? But let's do this. Let's get serious. Um, okay, so let's find the point first. Okay, so at t equals 1. Well, at t equals 1, x equals 1 plus 1 is 2. At t equals 1, 3 times 1 squared is 3. Alright, so those are our 2 points. Now let's find the slope at t equals 1. So same thing. Let's break this down. What is dx dt? Well, the derivative of t squared plus 1 is just 2t. And the derivative of dy dt is the derivative of 3t squared, which is just 6t. Now we just have to divide. So dy dx would be 6 t over 2t cancels, which equals 3. So that means our slope is 3 along the whole curve. So now we can write our equation. For me, I always found it easier to just do point slope form. So you can write it however you'd like, but I just do it like this: y minus 3 equals 3x minus 2, and boom. That is our answer, the equation of the tangent line at t equals 1. All right? Pretty simple, right? So now, this is one of the harder parts. You know, this is like the most important thing we're going to learn. And this is where most people lose easy points. All right? Most people make their mistakes on this. Even though they might understand it, they just, mess up. They're not thinking. So let's talk about it. If you want to find the second derivative, right, normally we just do this part, right? We just take the derivative of the first derivative. Now, for parametrics, you're going to have to divide by dx dt. Why? Because when we differentiate dy dx, you're actually taking the derivative with respect to t, not to x. So you have to convert it back to with respect to x. So this is kind of, think about it like a chain rule, all right? So remember, this is super important. You take the derivative like normal, and then you divide by dx dt. A lot of students get like so many points because they just forget. So it's really important that you hammer this into your brain. So let's use our example and take the first derivative first. First of all, let's take the first derivative. So dx dt would be dx dt equals 3t squared. dy dt is just 2t plus 1. And now what we have to do is dy dx would be 2t plus 1 over 3t squared. And let me just, highlight this in pink so I remember. I have to divide the derivative of this by 3t squared at the end. Now we have our dy dx. We're going to have to take the derivative of this. So we're going to need to use quotient rule. So let's do that. So the derivative of the top is just 2, and then we multiply by the bottom. And then subtract 2t plus 1, and then the derivative of the bottom is just 6t. And then divide all of that by the bottom squared. So 3t squared is just 9t to the 4th. Make sure you're obviously comfortable with quotient rule. So let's simplify the numerator a little bit. This would be 6t squared minus 12t squared minus 6t over 9t to the 4th. And this is the second derivative. So this is really messy. This is just d dt of dy dx. And this is the same thing, d dt of dy dx. Now we can simplify this even further. So this would be minus 6t squared minus 6t over 9t to the 4th. So now we have this as our, you know what, let me just make this smaller. Alright, so I just made everything a little bit smaller. So now we finished this part of the equation, d dt dy dx, right? That's this right here. Now our last part is divide by dx dt, which I circled in pink over here. So all we have to do is just divide. So let me just, whatever, let me just use pink anyway. The second derivative is equal to negative 6t squared minus 6t over 9t to the 4th, alright, divided by 3t squared, so that's the same thing as multiplying by 1 over 3t squared, right? And then this was just equal to negative 6t squared minus 6t over, what is this, 27t to the 6th. So we could factor this if we wanted to. It's not necessary. But that is our final answer. That is the second derivative. Let me circle it right there. This. Boom. Alright, so it's a little bit more complicated than just taking, you know, regular second derivatives, but it's not terrible, right? Remember, this is the most important thing that so many students miss out on, alright? Just remember, divide by dx dt. Alright? Now, our last question. Define the concavity at t equals 1. Now, if you guys remember, concavity is determined by what? The second derivative, right? So if the second derivative is positive, that means it's concave up. If the second derivative is negative, that means it's concave down. So let's find the derivatives. So first of all, we need to find the first derivative. So let me use a different color so we don't get confused. So dx dt is what? Well, 1 over t, and then dy dt is just 2t. So now all we have to do is divide. So dy dx equals 2t over 1 over t, right? But that's the same thing as 2t squared. And now we want to find the derivative of this. So d dt of dy dx is, what's the derivative of 2t squared? 4t. Alright, so now at t equals 1, if we plug this in, this equals 4, so that means it's concave up, right? No. What the hell, guys? I just said you can't do this. You need to divide by dx dt, right? So we're not done yet. So yes, our second derivative is this 4t, but we don't have it with respect to x yet. All right. So what do? We have to divide by dx dt like one more time. So that's 1 over t. So this would be our actual second derivative would be 4t over 1 over t. Hopefully you guys caught that. And this is just 4t squared. Alright? And now I know it doesn't change the answer, right? Because at t equals 1, the second derivative is 4. It's 4, and 4 is a positive number, which means concave up. But what if it wasn't, right? What if it changed something to a negative, right? What if this was like negative 1 over t, right? And then this would be concave down. So it's important that you guys remember that. All right, I kind of tricked you, but like we really need to make sure, because I promise you, like the parametrics are so easy if you just remember to divide by dx dt. I know I keep saying that, but it's like I can't stress it enough. All right, so that's pretty much all you need to know for parametrics for Calc BC. It's not something that's hard. Just takes a little bit of practice. I hope you guys learned from this video. If you have any questions or any future videos you'd like to see, please leave them in the comments below. Thank you guys so much for watching, and I'll see you guys in the next one.